Hi everyone, and welcome to today's SQL Office Hours session. Today, what we're going to do, we're actually not going to talk about SQL. Well, we will talk about SQL, but we're actually mostly going to be focusing on a slightly different topic. So let's imagine you've been asked to build a PL SQL API to do currency conversion. So what do I mean by that? Well, what we're going to get is a list of countries in, so Britain, Germany, Italy, India, whatever, and a price maybe in dollars or whatever currency it's in. We're going to pass those into our API function. And for result, what we want to do is for each of those countries, we want to return the local currency for it and the price in that currency converted to it. So Britain, we've got pounds, we've got 8.99, Germany and Italy, both euros, 8.99, India, rupees, and so on. Now, there's a few things to be aware of this. So when we look at these prices, we're going to get the exchange rates out of a table we stored in the database table. But these are all kind of nice prices, right? They're all something 99. If we just use the normal exchange rate, there's almost certainly we wouldn't get this. It would be £8.54 or 37 or something like that. We are going to do the exchange and then convert the value to a nice value. Basically, we're going to round up to whatever the major unit is, so pounds or euros, and then subtract off the minor units, so cents, pennies, that kind of thing. So we end up with a something 99 price. Then there are also some special currencies that we need to handle, or we want to handle. There's the XXX and XTS, the invalid or testing currency codes. If we get any of those as input, we're just going to return a bunch of nines as the output. It doesn't matter what the input is. Then there's some European bond currencies, so XB, they start XB. If somehow we get any of those in, we're just going to return null. So we get anything that maps to those. So there's some special logic and handling that we need to do here. So let's see how we're going to do it using the latest features in Oracle Database 23ai. So hi everyone, I'm Chris Saxon. I'm part of Gerald Wenzel's app dev team here in Oracle, and it's my job to help you get the best out of Oracle Database, have some fun with hopefully have some fun whilst doing so. So as I say, what we're going to look at today is how we can use features to build this API better. So we'll start off with that conversion function, the logic to get the exchange rate, take an exchange rate and a price and convert it into a nice price, right? So we will create a PL SQL function to do that. We'll call it Exrate conversion. And this is financial data, right? So we probably want to test this and make sure it's accurate. And it's a good chance we'll want to reuse this in other parts of the application too, not just our module the API we're building here. So we want to create a PL SQL function so we can test it, make sure it works, does the logic exactly how we expect it to, and so on. So we've got our function, and then we're going to have to build our API itself, which is going to call this. So the signature or this is going to look a bit like this. So the parameters, we're going to have a list or an array of countries that we want to get the currency and the final price for, and the input price, right? And we're just going to assume everything's dollars, right? You know, Oracle's a US company, so we'll assume everything's dollars there. So the question here is, well, a few questions actually. One question is, what is this country prices array? What is that? So that's a custom type. So it is a record of the currency codes and amounts. So for each country, we want to return the associated currency and the price in that currency, right? So at this point, we've got our record. You might go, we need to turn that into an array. So we're going to have an array of records. And this point you go, well, where are the countries in this? We're going to use the country codes, the ISO country codes, as the index for the array. So we can access the price for a particular country just by saying, you know, array, GB, D, whatever, and access into individual elements like that. So we've got those types, and our array is the input output. So we can pass in that array and set it up like that. So that's the kind of outline of the header for it. What is we actually going to do in the procedure? Well, we've got to loop through that array. We've got our array of countries, loop through them. And for each one, we want to get the exchange rates. So we've got the data stored in a table, find the corresponding currency for that country, find its exchange rate, and then do the conversion, call that function that we just built there. So we can do that and it will produce some code that looks a bit like this. So, this doesn't look too bad, but it's bit challenging. There's some things which are not too great about it. Let's start off with this loop. So we've got a loop and it is indexed by varchar2. You had to do a while loop like this. I mean, there's nothing technically wrong with this. It was the right way to do it. It is just a bit fiddly and a bit faffy to actually write the code. Next up, this is probably the biggest problem here, and that's a performance issue potentially. We're running a SQL statement on each iteration. We're just fetching exchange rate and conversion for one country at a time. If you want slow SQL, this is absolutely the way to do it, right? Write a loop and have a statement inside it that processes one row at a time. We want to process get all the data with one execution of that statement. Also, we're calling the PL SQL function in the SQL statement, right? And the SQL and PL SQL languages have different runtime engines. Every time one calls the other, there's a context switch, right? These switches are super fast, but you do anything lots of times and it can still slow it down. So we probably want to tweak this and improve performance. Finally, we look at our case expression for handling our special currencies here. And I'm not sure what happened there. Our case expression for handling our special currencies here. We've got our currency codes and we've duplicated the expression like that. Okay, and it'd be nice if we didn't have to do that. Okay, so let's look at how we can improve this and make it better. So to start off with, let's look at the loop, right, and see what we can do to make it a bit easier to write, a bit easier to understand. So like I say, we had a while loop like this to iterate through the array. And unfortunately, you know, it is a bit clunky. There's a lot of code to write, but it is just the way you had to do it, or you had to do something like this to kind of loop through an array, particularly one that is indexed by character data, as we have here with the country codes. So luckily, there is an easier way to do that. But before we get to that, let's just take a little side trip, a little diversion. Imagine you're in an interview, right? You're taking a programming test. And a lot of these interviews will give you some kind of challenge. So the challenge here is you're being asked to input from between values from 0 to 100, output all the values that are multiples of 3 and 5. So a FizzBuzz style challenge here. And also they ask you to do, again, for the values between 0 and 100, output those that are powers of 2, and also show the Fibonacci numbers, right? So you've been asked to write a PL SQL function or procedure that does this. So the basic way we do that, we're going to loop through the values from 1 to 100, just look at the multiples of 3 and 5, one way of doing it, check if something is a multiple of 3, if it's a multiple of 5, then output the row, right? Does the job, but we look at every single value here. We check every single value between 0 and 100. Now, modern computers and modern systems, this is so fast, it's probably not an issue. But if we really care about performance, we probably don't want to execute the loop body for every single one. We probably want to do this a little bit more efficiently. So the first thing we want to look at here is better loops, or more powerful loop controls. Now, this is something we actually introduced back in 21C, so a little while ago now. Now, 21C was an innovation release, so it will probably still be new for a lot of you. So we're not going to just talk about what's new in 23ai itself. We'll also look at what's was new in 21C as well, because a lot of you probably didn't upgrade to it. If you did, I'd love to know. Let us know if you actually started using that. So there is a lot of kind of syntax for this, and rather than just sit through some slides kind of demonstrating some syntax for you, what I was going to do is actually do a little demo. All right, so let's just run this. So we'll set everything up. So like I say, here is the way you would do this before. Loop in the values, and say if it is a multiple of 3 and 5, FizzBuzz will output everything. And as you can see, we've got our DBMS output. We're checking every single value and saying it's a FizzBuzz if it is a multiple of 3 and 5. Okay, so this was the original, the classic way of doing this. Okay, but it'd be nice if we didn't have to check every single value. You know, rather than checking every value between 1 and 100, we could take some shortcuts, right? We can actually specify now, starting in 21C, a custom increment. So we say by fizz, So this means rather than increasing by 1 each time, we increase by whatever this is, so 3. And then the when clause, we only enter the loop body if this is true, right? We're saying if it is jump up in multiples 3, check if it is also a multiple of 5. Is it in? If it is, then run this code. Now, at this point, this mod here is a little bit redundant, right? Because we've actually already checked that. But it's just to kind of show you that now we are actually only running the loop body for everything that is a multiple of 3 and 5, okay? So we have reduced the work that the code is actually doing. So all of the things being equal should make things a bit faster. Now, the maths whiz amongst you will notice that, I've done 2 things here. I've gone up by multiples of fizz, or 3, and then I've entered the loop body if it's also a multiple of 5. That's really just to show there are 2 kind of clauses here. We could, of course, simplify that and just say it's a multiple of 3 times 5, or, increase by 3 times 5, fizz buzz. So this really does the same thing. So we can simplify it even further. So the by changes the step increment when we still check the value, and that decides whether we actually enter the loop body and run whatever the code is in here. So we can use this to specify custom increments, but the values here are still just integers, right? They're 1, 2, 3, 4. Nice thing in 21c is we can also specify non-integer increments. But to do that, you have to specify a data type for the loop iterand, so the loop variable. So we've got our n here, it's a number, and we're saying between 0 and 1, jump up by a tenth, 0.1 each time, and there we go. We go 0.1, 0.2, 0.3, 0.4, so on and so forth. So we can specify our custom increments. We can also do this for non-numeric data. So we could loop through some dates. So we've got some dates here. I notice I've got 31st of December, 99.99 up to today. This doesn't loop through all the values between those 2 dates. It's not every day between them. It is a list of dates, right? We've comma separated these. So we're saying just this value and then just that value. So we only get 2 rows, not however many days there has been so far this century, basically, right? So when we have a list of things, it is those specific values. And we can also do something similar for string values. So we say it's a string and list some country codes, for example, and list those out. Pretty neat, right? So we've got a lot more power and control to loop through particular values. And we saw we could use it to specify a custom increment, so solve our fizz buzz to jump up in multiples of 3 and 5. But what about our powers of 2, right? There isn't a constant increment each time. It doubles every single time. How do we do that? Well, there is also a repeat expression. So it says repeat this, keep doing this, start with a value of 1, do this thing, the repeat here, until this is false or it's not true. We can run this and we'll see it goes up and it goes 1, 2, 4, 8. So the first time, start with that, then next loop round, run this to double it, and keep doing that until this is false. Now, what's going to happen if I get rid of this? Oh, dang it. What am I doing here? I'm losing my, let's just make sure I'm attached my thing. I've trying to be too clever, right? There we go. If I take, what am I doing? Okay, forget that for a minute. All right, so that will keep going until that is false. Okay, so that's our powers of 2. There is another way we can solve this. You can do it with mutable iterands. So we're saying this is mutable. That means you can actually change its value inside the loop. So notice we're saying it's mutable here. And then inside the loop, we're setting what the next value is. We're doubling it. So as we can see, that gets those values like that. Now, as I say here, you should be very, very careful about doing this. Only use it if you really have to. You can't think of a better way, a more obvious way of doing it, because it is super easy to make a mistake with an infinite loop or just not doing what you expected it to do. An interesting thing to note here is, you notice I'm subtracting 1. It's like, why am I subtracting 1? Well, that's because even though we set its value here, when it comes around and runs the loop the next time around, it still increments it. So if I don't subtract 1, notice we get odd values here, 1, 3, 7, and so on. So we need to do that. So like I say, it's there if you need it, but it's very, very rare that you should need it, okay? If you think you need it, think again. Probably need to find a better way of doing this. Okay, so we can see there's various ways we can use an expression to change the value. So we can use a repeat or mutable variables, index variables. And we'll do a similar thing for Fibonacci's. So again, we'll start with 0 and 1. So we just got a list of these values we're going through. Then we'll keep adding the two previous numbers together with our while loop and then get our output like that. So there we go. And we got our Fibonacci's up to 100 as well. Pretty neat, right? Now, if you want to be really smart, really want to show off, you can actually combine all of these into one loop. Like, wow, it's crazy, right? So start off with, we're going to loop from 1 to 100, and then our custom increments of 15. And then notice the comma separating. So this means we've done that. We're then going to go back to 0, 1, and then do our repeat while expression, so our Fibonacci's. Then we're going to go back to 1, start again, and do our powers of 2, and things like that. So we can actually do all sorts of kind of really powerful things and chain lots of loops together like this. So again, we've got 0, 15, 30, 45, our FizzBuzz numbers. We've also got our Fibonacci numbers, 0, 1, 1, 1, 2, 3, 5, and so on, and then our powers of 2. All right. So you've got any questions, comments on that, then please let me know. I know someone is asking about my code formatting for the VS Code extension. Honestly, I can't remember now. It's been so long since I've used this. I'll have to check. So actually, one thing to note here is I'm using the Oracle SQL Developer extension for VS Code. So the old SQL Developer desktop version is where they're moving away from that, and the strategic way is going to be the VS Code extension. So there's still some functionality which isn't here, but they are updating regularly. So I'd strongly recommend you at least check it out and see how it works. And if it doesn't do what you want it to do, let them know, give them feedback, because they are super keen to hear. So Jeff Smith is the key guy you need to get in touch with now. I'm just kind of losing track of things there. All right then. So we can see we can do all sorts of powerful, cool things with our loops here and chain them all together. So at this point, you might be thinking to yourself, well, that's pretty cool. That's pretty neat. But when am I going to use this, right? What's the point of all this? Well, the answer is you're probably not going to use it that often. Like I say, these extra controls are very useful or very powerful, but it's not that often you actually need to use them. However, there is a new improvement to loops, which certainly I've used a lot, and hoping you will probably use quite a lot as well. If you've been a PL SQL developer for a while, you've probably written some code that looks a bit like this to loop through an array. So start from 1, go up to the array.count, and iterate through the elements in the PL SQL array. That's all well and good, but it makes a couple of important assumptions. First up, that there is a numeric index for this array, and there are no gaps in them. So we start at 1, they go 1, 2, 3, 4, up to however many elements there are. If we go, the indices are 1, 5, 10, 100, this won't work. We'll get no data found exceptions. So this does the job as long as you hit these, are within these restrictions. And then critically, this doesn't work for our countries array. Why? Because it's indexed by varchar, it's indexed by string, so we cannot do that, and we had to do that loop code that we had before. So fortunately, there is a much easier way in 21C we added to do this, the values of and indices of clauses. So those of you who are familiar with for all bulk processing have these clauses. It's exactly the same concept. We're saying, look at the values in the array, and we'll set the index loop variable val to whatever those are. Right? Or we can use the indices as well. There is another enhancement to this. There's another form of it, and that is the pairs of control. We can actually specify 2 loop variables, the index and the value. And so we're getting the indices and the value from the array. That could be useful in some cases, save us writing a little bit of code to actually pull them out. So what that means is, critically for our API, rather than having a while loop like this, we can just change it to all country and indices of countries. Wow, that's pretty cool, right? Much, much better. First up, it's hopefully very obviously much less code, right? Secondly, there is no chance of writing an infinite loop, right? If with that while loop, if you get it wrong, you can end up with an infinite loop by mistake. I know I've done it at least a few times, more times than I'd care to admit. Fortunately, they've never made it into production code, but still, these things happen. And finally, personally at least, I think this code is much more self-documenting. If I showed you this code or you show this to someone else, they could probably make an educated guess as to what it means. Whereas compared to that while loop, I mean, you might get there eventually, but it's not immediately obvious, particularly if it's a really big loop or lots of stuff going on inside the body, and the assigning the next value is on a different page or something like that. So overall, this just makes these loop controls much more powerful. Like I say, these array controls, personally, I think are where you get the real value of these loop improvements. So just to recap on those, we saw we got the ability to skip over variable values and loops now. So in the past, PL SQL loop variables were always integers that incremented by 1. You can now bypass the loop body by specifying a when condition. So you only enter and execute that when something is true. We can also specify custom increments. So that could be a constant value, so increase by 2 each time, or it could be an expression, double the value, set Fibonacci's, some other kind of formula to change what we're incrementing there. Finally, we got options, lots of options to actually loop and through arrays as well, making that code much simpler to write, much less error prone, and as like I say, in my opinion, more self-documenting as well. So someone had their hands up. If you've got questions, like I say, just put questions in the Q&A. I'll keep half an eye on it, and I'll answer them as I go along, or as best I can. So if you any questions or comments on that, let me know before we move on. I'll just get a little drink. So like I say, if just put your questions in and I'll address them as best I can when I can. Alrighty then, so we've improved the loop, or we just made it and tidy the code up a bit more clearer and obvious. Let's move on and let's look at probably the thing that's actually more problematic or something, and that is performance. So like I say, in the past we had the loop, and on each iteration through it, we were looking up the exchange rate for each country. So we're having one run of the SQL statement, get one row. Yeah, as I say, if I wanted to write some slow database code, this is the first thing I do. I'd have a loop and stick some SQL inside it that process one row at a time. What we really want is to get all the data in one fetch. So execute it once, get all the rows. So there is a way we can do that, but before we go that, we're going to again have to take a bit of a detour and talk about qualified expressions. So again, this is something that was introduced actually a little while ago. So back in 18C, we introduced qualified expressions. So qualified expressions, what does that mean? Come on, explain it in some real terms. Well, basically, all PL SQL types now have an implicit type constructor. So they automatically get it. You don't have to write any more code. So all record and all array types. So if you want to initialize an array, we can do like rect type and have the attributes like that. We can do something similar for an array. And for records, this works pretty well. But with arrays, it's a bit more challenging because you need to know how many elements there's going to be in the array and what the indices are. You basically need to hard code them. That can work quite well for ad hoc one-off things or test scripts and things like that. But generally in production code, you don't even necessarily know how many elements there's going to be in the array, right? So this can be a bit impractical in production code. So what you'd have to do is typically then you loop through the values. So using the 21C syntax, we could loop through our list of country codes and then initialize the entry for that country like this. However, in back in 21, yeah, still on 21, make sure I'm getting the right version, right? You can actually make this even simpler or change this even more and push the loop into the type constructor. And what does that mean? All right. Well, we've got our array variable and we've got our array type. So notice we've got the for statement inside the constructor. Wow, well, that's pretty cool. So it's looping through what these values are and assigning each element to those values. So GB, DE, IN, and so on. So that's great. But it's like, well, what's the indices? What values are actually indexing those arrays? Like ones, characters, what are they? Well, there's a couple of clauses that you can use to control that. So there's the sequence. So start with one and go up to however many elements there are in our loop, or how many things there are in our loop. Or there is the index clause. So we can actually specify a custom expression here. So here I'm saying C, the loop variable, is the index and it's the value. Okay, so they're all the same thing. What's the point in that? But anyway, key thing here is I'm now using those country codes as the index values for the array. Okay, so pretty neat, pretty handy, right? Pretty useful for initializing our array of countries. However, it gets even more interesting and more useful. Instead of a list of country codes here, this can actually be a query. So we can initialize it using a cursor for loop, essentially. So we can do something like this. We've got our array type, that's our array, and for CN, our query to get to the countries there and the exchange rates and do the conversion for the price, we can initialize it all in one go. Key thing here is now we run the SQL statement once. Instead of having to loop through the values and run it each time, fetching one row at a time, we run the SQL statement once and fetch all the rows in one go. Like I say, if you want fast SQL, this is the way to do it. Right? So this is looking pretty neat, right? We're getting all the values in one pass and potentially improving performance, but we still need to assign the country codes as the indexes for the array. The good news is we can use the index clause, right? We can actually use a column as the value for the indices. And this is something that just wasn't really possible in earlier versions of Oracle database. I mean, you could do it. You could bulk collect everything into a temporary array indexed by integer, but then you'd have to write some code to shuffle everything around to convert it to an index by string array. Now you can just do it all natively in one statement like that. Pretty cool, right? And like I say, this is the big thing to help improve the performance of your code. So we've initialized that, but there is still this question of this PL SQL function here, right? As I say, the SQL and PL SQL languages have different runtime engines. So there is a small hit to performance every time we switch from one to the other. So this is the classic dilemma here. What do we care about more? Performance, speed of the code, or code reuse and maintenance, right? Like I say, this is financial data, doing this exchange rate. And we created this function so we could test it standalone, make sure it gave the right results. And probably we're going to need to reuse that in other parts of the application as well. So we really, really want to have this PL SQL function here. But maybe this currency conversion API is a critical piece of the infrastructure. It's a core component, and it needs to be as absolutely fast as possible, because that's how we get, it's executed so heavily. So we need this to be as fast as possible. So that means that in theory, we should rip the logic out of the PL SQL function and paste it directly into the SQL statement. And it's like, what do we do here? Which is more important to you, performance or code reuse and maintenance? Well, of course, the answer is both. You want both, right? You don't want to have to choose. You don't want one or the other. Fortunately, we do offer a way out of this dilemma, and that is Scalar SQL macros. So before we kind of show exactly how that works or why that works, a bit of background on SQL macros. So SQL macros come in two flavors, table and scalar. So table macros return a query, and you can only use them in the from clause. So the from clause of select statements. Scalar macros, on the other hand, return a SQL expression and are analogous to a PL SQL function, and you can use, as I say everywhere else, there are still a few limitations, but you can use them in the select, the where, the order by, and so on and so forth in your SQL statement. Basically, everywhere it's legal to use a PL SQL function. Another thing is SQL macros were a 21C feature, but table macros only were backported to 19C. So those of you, which I think most of you probably still on 19C, hopefully most of you are on 19C, maybe a few of you are on 21C. Table macros are available to you today, but I'm going to focus on scalar macros because they're what we're talking about in terms of PL SQL functions. Like they're the closest to a PL SQL function. I see a comment, qualified expressions are the coolest PL SQL enhancement I have seen in a while. They are very cool. I think there's a cool one. hold that to the end of the session, and if you still think it's the coolest, we'll have a vote about which we think is the coolest, because I think there's something cooler I think is coming, right? But I agree, they are cool. Right, okay, so SQL macro. We're going to talk about scalar macros. So we've got our SQL macro, and we have to create our function, and we'll use this SQL macro clause to say whether or not it is table or scalar. Okay, now those of you who are paying attention and looking at this code closely will notice I am returning a clob, right? Now, it doesn't have to be a clob, it could be a varchar, but it does have to be a string. All SQL macros return text, they return a string. Okay, so, and that string is the function, the expression. Okay, so if we have our exchange rate conversion function, and in the past it was returning a number and it was doing this formula, to convert it into a macro, we change the return type to some string type, say it's a scalar SQL macro, and we put quotes around the formula. So we turn that formula into text. And by doing that, the names of the parameters in this string effectively become placeholders. So we got Exrate, price, and minor units are the parameters. At parse time, when parsing the statement, the database looks for these parameter names in that string and essentially does a find and replace. So think of it as a textual find and replace. It is a bit more advanced than that, but if you think it's just looking at the actual, whatever it is you've actually typed to call that function, the actual text of that, and swap it in for those placeholders in that string. So let's see how this works, what actually happens in practice. We've got a SQL statement, it's calling the macro. So conceptually, the first thing the statement does, the optimizer does when parsing it, is replaces the function with the expression, okay? So we kind of rip that function out, forget that, the function no longer exists essentially, and we've got our formula pasted into the SQL statement. We then swap those placeholders for the actual text of what we supplied here. So here we've got a bind variable, a column name, and a literal. So essentially it looks for those and swaps them in. So we wrote, the code we wrote was select the exchange rate macro. What the database actually runs and executes is the formula within it with those placeholders plunked in. Notice it's still the bind variable. It doesn't, bind variable peaking still happens, but it doesn't look at the value of the bind variable and swap that in. It still persists that bind variable in the final SQL statement is what we get. So what does this mean? Well, if we've got a SQL statement like this, where we're calling our macro, that means at runtime, there is no context switch, right? The function effectively doesn't exist, right? It's gone. It's been converted into pure SQL. We no longer have that overhead of switching between those two languages. There is another potential benefit here as well, because at least by default, the optimizer doesn't really understand or know what this function is doing. It's a bit of a black box to it. By converting it to the underlying expression, the optimizer gets better visibility of what's going on within it, improving the chances that it will use indexes on the columns and improving the chances of getting better row estimates. Now, those aren't guaranteed, obviously. There's lots of things that mean those might not be true, but it does improve the odds compared to a regular PL SQL function. So this is pretty cool. But at this point, you might be thinking to yourself, well, I don't want to have to rewrite my functions, right? We actually have to change them. We have to change the return type, well, potentially change the return type and quote that formula, okay? So there's some work that you need to do here. And actually, there's a bigger thing that we need to look at here. And that is if you call these macros in PL SQL, right? They are SQL macros, not PL SQL macros. That substitution, that replacement, all that lovely stuff I just talked about, that only happens in SQL. If we call it a macro in PL SQL, you just get the text back, right? It literally just returns you that string. Okay, so potentially we've still got a bit of a dilemma here, right? We've still got something to think about. If we need to call this both in SQL and in PL SQL, what do? Do we have two versions of the code and have to make sure they maintain and stay in sync? Do we have one call the other? So there's still some thinking and some trade-offs we need to think about here. However, 23ai introduced another better way out of this, and that is the automatic SQL transpiler. And personally, I think this is the coolest thing in PL SQL for a very long time. Okay, but like I say, we'll have a vote later, see what people think. automatic SQL transpiler. So what does that mean? Well, first up, let's just convert our function back to a regular PL SQL function. So we're making it back to a numeric thing and run our formula. So it's standard PL SQL function. To use the SQL transpiler, all we need to do is set this parameter to on. That's it. The transpiler is now enabled. And if it is able to do so, the optimizer will rip the expression out of the PL SQL function and do that work of essentially do the work of the macro, but without you having to code it and write it yourself. So we can do this. We can have our where exchange rate conversion PL SQL function. The database has ripped the logic out there, done the substitution for you, and it has converted it into pure SQL. So if you look at the plan, you'll see we'll have something like this. Rather than the function in the predicate section, you'll actually see we have that underlying formula. So the function, again, at runtime no longer exists. And the cool thing is we only had to change, flip a flag. That was it. You didn't have to write any more code for you. It is transparent to you. So at this point, some of you might go, well, why did they talk about scalar macros? What's the point in this, right? Why do we need scalar macros if we've got this automatic SQL transpiler? Well, first thing is, this is version 1 of the transpiler. So there are a lot of limitations on it at the moment. It can only transpile things that are SQL expressions that resolve to SQL. Critically, at the moment, that means if there are any SQL statements, select, insert, update, delete, whatever, it will not get transpiled. Also, and currently as things stand, if there is any PL SQL constructs in that function at all, anywhere in it, it will not get transpiled, okay? So these limitations should change over time, but as things stand at the moment, there are a lot of things which won't get transpiled, which you could do as a macro. So let's jump over to a demo and see these in action. I see there's a question or comment from somewhere. So SQL macros resolution is all at compile time, right? Yeah. Or is it runtime? I played with them a bit, but find them a bit confusing. Macros in C are compile time and only and easily understood. May the transpiler will make this clear. Yeah, so it happens when parsing the SQL statement. So it's only the parse for the SQL statement. And if you don't realize this can lead to some unexpected surprising behavior, which catch people out. The key thing is all the logic needs to be in that string, okay? If necessary, we can talk a bit more about that later. But yes, it is a parse time resolution, not a runtime resolution. Yeah. Exrate, if you've got questions on this, we can talk about them a bit more. So let's start off. We've got our current trees. Actually, I don't think we've got some tables. Actually, I don't think I need those here. So here is our function. Here it is, the original version that we had. And if we look at the plan for this, so we got the plan, and you can see, hopefully, in the filter section, we have got our function call. Okay, so that is happening. That's what the database is doing. It's calling this function for each row, essentially. Let's turn it into a macro. So as I say, we've got our clob, and notice we have turned this all into a string. So let's do that. So now, when we look at the plan, and we look at the predicates here, we can see it has extracted that formula, that function, out of the function, and at runtime, it effectively doesn't exist anymore. Okay, so we are doing pure SQL at this point. Okay, so but however, like I say, this resolution only happens in SQL. If we call it in PL SQL, notice we are just getting the string back, right? So it's like, oh, it's a bit of a dilemma here. What do we do? Which is the right? Which should we choose? Do we need to do both? So let's bring in the transpiler, and I've messed my things up. Let's enable the transpiler. There we go. Or we just enable it to on. And if we look at the plan now, notice the filter, the function does not exist in the plan anymore, right? It is literally ceiling of 99. That's our value passed in. The exchange rate column. Notice I said it was just a find replace. It is a bit smarter than that. It has a table aliases and things like that. And then we got the minor units, which is column in the table. So at runtime, the function is gone. However, they say version 1 of the feature, a lot of restrictions. Let's show a very simple one, which might catch you out. Dummy variable. It is not used anywhere in this function, but it uses %row type. %row type is a PL SQL thing, right? So this won't get transpiled anymore. Let's just compile that, check the check the plan, and we're back to calling the function here. Okay, so like I say, this is version 1. Expect obvious, simple things like this to be removed at some point in the future. I don't have timescales, don't quote me on exactly when, but things like this we hopefully will transpile one day. However, that does imagine, let's say we're a few years down the road and we've transpiled all the obvious stuff, right? All the simple stuff. Where does that leave SQL macros? They're still like, why bother them? What's the point? Well, there are some things which are valid in SQL, valid SQL expressions, but invalid PL SQL, right? So the collate clause to do case-insensitive comparison. This is not valid PL SQL, right? When I try and make a case-insensitive PL SQL function like this, it won't let me do it. I cannot return this expression because I don't understand that, okay? However, that is a valid SQL expression, okay? So if we turn this into a macro and quote it, turn it in SQL, that is a valid PL SQL. So now we're doing a case-insensitive calling the macro. Notice king in uppercase, but we get king with it in lowercase, right? There will still continue to be things which are valid SQL expressions, which you cannot compile into PL SQL, okay? So those will be some point in the future when all the restrictions have been lifted. It will still be a use case for scalar macros. It will just be those things that you can only do in SQL and not PL SQL. All right. So questions, comments. I'm sure people must have some questions on this. I see. Okay, so okay. People think you think the transpiler is cool, but qualified expressions are cooler. Okay, let's have a. Let us know in the chat which you think is better, say transpiler or qualified expressions, or T or QE, whatever. Okay, like I say, I think they're both cool. Personally, I think the transpiler is better, but we can disagree on this, right? Okay, so question. When should you not change your function to SQL macros? So when should you not change your function to SQL? Well, like I say, if you need to actually call it in SQL and PL SQL, right? And of course now with the transpiler, assuming you can simplify it, if there is PL SQL only stuff in there and you need it, you'll have to think about that. But if you need that functionality in SQL and you need to call that function in PL SQL, you need to think about it. What's the best way forward? And it's it's a decision you have to make of the trade-offs of potentially maintaining two code bases, performance overheads, things like that. All right, so that's something you'll need to think about as a team. I don't know if that hasn't answered that. Ask again, let me know. So why is it even a choice? Why is it not on all the time for SQL statements? I'm assuming you mean the transpiler. Why is the transpiler not on all the time? Well, that's a very good question. So this is a new feature, right? And generally as a rule in Oracle database, when we add a new feature, we enable it, we put it in disabled and allow you to enable it. Why? Well, we're super cautious, right? This affects potentially every function call in your database. Let's imagine we deployed this in 23ai and there was some problem with it, okay? Then, even a tiny problem with anything like this, there's so many lines of functions in code around the world, the effects could be catastrophic. So we put it in disabled and a future release will make the default on, right? So that will happen at some point when we've got better confidence in how the feature is working. Key thing here is that this, there aren't any particular downsides at the moment, right? Some things it's like you switch it on, you're potentially losing other functionality. That's not really the case with the transpiler. You can just switch it on and you're done, okay? Either it's transpiled or it's not. I'm not aware. The only reason you would ever turn it off is because you encountered some bug, right? As far as I'm concerned, there might be some in the future that might change, but that's how things are currently. So you say if you want to just, as soon as you upgrade to 23ai, set it at the system level to on, you're welcome to do so. But it's a big ask for us to enable that for all code for everyone across the entirety of Oracle database. And that's just a general principle for all new features. They're added disabled, and at some future release, they are enabled. Okay. How do you use it in functional indexes? Okay. I mean, the transpiler is transparent to functional indexes, but the point is you don't need to create the function on if you. So let's go back to our formula here, like this. Now, if we could, rather than creating a function index over the PL SQL function, you would create a functional index over this expression. Now, it's not possible in this case for various reasons, but the key thing is you're not creating a function-based index on the PL SQL function. You're creating a function-based index on what's inside the PL SQL function, that expression, right? So you might still need them, and there is still a difference there, but it's one thing. So there is a subtle difference there. If there's something more you want to know about that, need to know. So why is it that using DBMS expand SQL text does not always show the resulting SQL statement after the SQL macro replacement? Because the work hasn't been done yet. There is an enhancement request that will come in the future. It's just not happened. Okay, it will in the future. Okay, I can come back to that later for those who are not really sure what I'm talking about. That. Super cool. May the transpiler always be with you. Okay, cool. It's great to see videos. Think about that. Alrighty then. Not seeing any other questions or comments on that. Like I say, some of these things we can dive into a bit more detail later on, but got more stuff together. Let's move on to that and we'll come back to those later potentially. All right. So let's just recap that in terms of other kind of performance things we looked at. So initializing arrays so we can load them with SQL. Now, previously you could do this with bulk collect, but bulk collect could only load in arrays that were indexed by an integer and they were densely populated. If we want to load in something indexed by a character or a date or something like that, it wouldn't work. You'd have to take multiple steps here. So it's much simpler to do that. We looked at how we can use macros to change our functions to macros so we're down to pure SQL. However, that substitution only happens in SQL. Or in 23ai, we've got the transpiler, which can just do it for you. However, if what you are trying to reuse is SQL, a SQL expression, you will have to use a macro. Right, finish up. Let's just look at some code reduction stuff. So, as I said, we had our case expression, and we're doing the same thing. We're looking up the currency code and returning a different result as appropriate. It'd be kind of nice if we didn't have to do that, if we just had to list it once. And actually you can. We can make a simple case expression like that, but now we need to list out all the possibilities for this. At least in this case, I'm not sure this is any better, right? We've probably got a lot more options to list here than just those two we had. But it'd be nice if we could get the best of both worlds, right? If we could just list the expression once and then have our conditions once as well. Well, the good news is in 23ai, you can with extended case controls. What does that mean? Well, you can now have like a simple case expression, just say case expression, and then we can do things like this, have a condition here, okay? So the expression in, like, less than is null. Whoa, pretty much all the SQL expressions are supported. So at this point you go, what does this mean? What's actually going on here? Well, just imagine implicitly that expression is already on the left-hand side of this condition here. We call it a dangling predicate, right? So just imagine that this expression is copied here, but you only need to list it once, okay? So what that means is, instead of having to duplicate our currency code, we can just list it once like a simple thing, and then have complex conditions to check which value it actually is. So small thing, nice little thing, just makes your code potentially a bit easier to write. One thing to do note about this, case expressions are SQL and PL SQL. However, this enhancement is currently only in PL SQL. Hopefully it will come to SQL one day soon as well, but currently this is only in PL SQL, right? So just bear in mind if you're trying to write this code, and this also has an impact for the transpiler as well. We tried to transpile this, it's PL SQL only, so the transpiler won't do it. Okay, so a small thing, but there's a lot of little small things in 23ai, and there's a lot of small things can make up to a big difference, right? So one final thing, we've talked about this at API, but so far we've been dealing with PL SQL record and array types. Chances are most kind of mid-tier developers, they don't care about that. They don't want to talk PL SQL types. they want to talk JSON, right? They want to pass in a JSON array or JSON object of the countries and get back a JSON object or array of the values, the prices in each country and currency. So the good thing is in 23ai, to convert PL SQL types to JSON and back again is super easy, right? To take a PL SQL, to take some JSON and turn it into a PL SQL record array type, you just specify that as the returning type for your JSON value. That's it. You don't need to do anything else. The database does the mapping for you based on the attribute names in the record, or if it's an array, the indices of those. If we want to go back the other way and got an array or record we want to convert to JSON, it's even easier. You just pass it to the JSON constructor and you're done, right? Okay, so again, there are some details. So let's just jump into a demo and look at those in a bit more detail. Okay, so let's look at the case expressions. So I'm saying for a country code, I want to find the currency for it. So here, Britain. Now, just to be super certain that the values are in fact uppercase, who knows? They may not be in, they could be in lowercase. I'm going to uppercase it in the case expression. So with our classic simple case expression, I'd have to list out all the European Euro countries separately. That's a lot of typing, a lot of unnecessary work, potentially. Or we could go with a search case expression and do something like this, and we could list them all here. Again, it's a bit better, but we're duplicating this, introducing the risk that we might make a mistake or something like that. Or in 23i, we can just list that expression once and say if it's GB or it's in those values or it's like those. Well, hey, and these all do the same thing. It's just slightly different ways of doing it. Okay, let's look at those JSON to PL SQL and back again. So I've got JSON array here, 1, 2, 3, and I've got a V array, so a PL SQL V array. To convert it, the JSON to a V array, I just return the V array, loop through them, and then convert it back to JSON like that. And we can see we get the values 1, 2, 3, and we get back an array 1, 2, 3, right? From the JSON to the type and back again. Let's look at now. Personally, I don't use V arrays very often. If you do use V arrays, I'd love to know. Actually, I don't think I've actually seen them in the wild really, but most of it is either use nested tables or associative arrays. So let's see what happens when we do those. So we've got a nested table here. Otherwise, it's exactly the same code. I'm just changing the type here. And we can see we're getting our values here, but something interesting. It is no longer JSON array. It's like, what? It's not an array, it's an object. What is going on here? So the index values are the attribute names in the object. And at this point, you're going, some of you are probably a bit mind boggled. It's like, what's the point? Why do we do that? Well, a nested table, an associative array is not guaranteed to be densely packed. There could be gaps in the indices, and those values could be important. They could matter, right? So for example, let's delete the middle element. We'll delete 2 from the array here. So we now got a gap here. We've only got the values 1 and 3, and the indices are 1 and 3. In general, those index values could be important, okay? So we preserve that information. In particular, we've got an array of countries indexed by character. Our country codes will become the attribute names here. So it's just to preserve that information, okay? So do bear that in mind when you're doing these kind of basic conversions like that. All right, let's now actually get on and build our API. So here's our package spec. That's the original implementation. Here's the original implementation. We've got our while loop, our row by row processing, our function call, and our old school case expression. So we can do that. And like I say, does the job. We've got our array of countries. We're going to initialize them, and then we had to loop through them with our while loop like that. We do that, call that, and we can see we've got our converted values, and we've got our XX country, which has the testing, 99999, bunch of 9s as a result. Let's 23ai it. Let's improve it. Okay, so first thing is I'm going to do. Now I'm actually going to create a internal array, which is indexed by integer, and just essentially convert this array, get the indices of it to be the values in the array. Okay, why have I done that? well, I can then use this internal array variable in the SQL statement. So I can join to it like this, allowing us to initialize all the values in one go. And then we can get the country code from it as the index. And then we've got our pairs of syntax, IMV, so we can see for the currency code, set them and set those as appropriate. So there's our implementation. Let's call it. Now this time we're going to pass in JSON. So notice we've got a JSON object. Each country is the attribute. To convert that JSON to our countries array we're passing in, we just pass it to JSON value. Job done, right? Pass that into our thing, and then to loop through the values at the end, we can use our pairs on the syntax. Say the country, the index, and get the price, the value for those in each one to simplify our code like that. Or if we want to see it as JSON, we can just pass it to the JSON constructor. I've just JSON serialized it to make it text and a bit easier to read. And we can get our output like that, and voila. There we go. We've got it, what we had before, looping through, or we got it as JSON. Now, one tiny detail that some of you might have missed, and if you're paying close attention, you would have noticed, I passed in a non-existent country, ZZ. There is no ZZ country, okay? What would have happened in our old API if we had passed that in? Well, we were trying to look up a row which didn't exist in a table. What's going to happen? No data found exception, right? The whole thing would have fallen over in a big heap. Now, because we're kind of joining to this and outer joining to it, we can get it back as our output. Now, there's still some discussion about what's the best or the right way to handling this is. Obviously, it will depend on the contract you have with your consumers and what you want to do, basically. But it's just an interesting little detail. We didn't need to write that no data found exception handler to manage this case and stop it throwing an error and the whole thing failing if someone tries to pass in some dodgy country codes into us. Okay. All right. So if you've got some final questions or comments, put them in. I will address them. We're nearly at the hour, so we'll just wrap up quickly, and then we'll have some bonus time for those of you who want to hang around, and we'll discuss these in a bit more detail. So just to recap on those final things, looking at less code, we saw the extended case controls with the dangling expression. You basically can use a simple case expression and compare it to as we say, a dangling predicate partial condition. And we've got easy ability to convert JSON to PL SQL types and back again. So just to kind of reiterate on what we had here, we had our kind of clunky while loop, which was just the way you had to do it in the past. We had our row by row processing and our function call and duplicating our expression in our case statement or case expression. Here's our new version of the code. First glance, it doesn't look necessarily much simpler or less, but the big thing here is this query we are running once. So this is really significant for performance. Like I say, this is core critical code, and you need it to be as fast as possible. Getting all these values in one pass can be a big time saver. We can also make this conversion function, either use the transpiler or make it a macro, depending on what we need to do and what we want. Finally, this little case expression I've got here, in reality, I'd probably stick it in that function as well. I just kind of split them out just to kind of help demonstrate some of these examples. In reality, we'd probably stick this logic in there too, so we could simplify the code. And essentially, we may even really just have one statement, initializing the array based on the SQL statement. So PL SQL and 23ai are using it to build better database API. So we had much more powerful loop controls, and this is actually a 21c feature, right? So this has been around for a while. Any of you who are running on 21c can use this today. We looked at ways you can make PL SQL function calls in SQL faster through macros or the transpiler. Again, macros, scalar macros are 21c. Table macros backports to 19c. Didn't talk about those today, but they're hopefully available for most of you. We've got the transpiler. And just generally, there's lots of little things to help you write less code, right? Extended case controls, JSON to PL SQL conversions. If you want to have a little test and see how much you know about PL SQL, over on DevGym, we've got a little workout of 23 quizzes. This has actually been around for a while. It's kind of coincidental. It's actually 23 quizzes, but it's a whole stack of PL SQL topics. So if you want to just like test your knowledge, see what you know about PL SQL, please check that out on Oracle Dev Gym. It's a great learning platform to help you understand and work with Oracle Database, SQL, and PL SQL more effectively. With that, all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something, and we will see you all next time. Goodbye.